Hello and welcome to the VHDL Entities and Architectures lecture. In this lecture, I'm going to explain what a VHDL entity and architecture are. Every design in VHDL requires one entity and one architecture. At a high level, the entity is what explains the over-encompassing or the inputs and the outputs of your design. So when you have a design, you can think of what are the inputs and what are the outputs. The entity defines these inputs and the outputs. And inside the entity, you define if they are one, an input and output, or bidirectional. Those are the three types of modes you can have, either an input, output, or an in-out, which is a bidirectional type of signal to your entity. And when you define the entity, it's in the following. You have the name, the direction, which is where the in, out, or in-out, the bidirectional, the data type, and then optional, you can also define what the initial value is. So for example, if you would have an output, you would say the name of that is called C, and we'll define it as an output, and the data type, which we'll call, say, a standard logic, and the initial value of just a zero or a logical low or false. So let's go ahead and take a look at the entity example. An example of an entity would be, we're going to take a very basic look at an AND gate. So if we have an AND gate, just a simple logical function here, we have two inputs to our AND gate, which we will call A and B. And we have the output, which we will call C. So we want to represent this in VHDL, this very simple AND gate. So our entity is our inputs and our outputs. So we know that we've got our inputs, which is the A and B, and our output, which is a C, is defined in our entity. So this is what we want to define inside of our entity. And how would we do that? Well, we would use the entity keyword. So we would say entity, and then we give it a name. And for our name, we're just going to call it capital and underscore gate. And we'll see where this is relevant when we get to the architecture. And then we use the keyword is, and here is where we define our entity. So we want to use the keyword port, P-O-R-T, and then we'll do an open bracket, and we want to define, first we'll define our inputs, so we'll define our A, and then we'll use the colon, and we want to define the direction, which is an input, which is defined by the keyword in, and the next thing we would define is the data type, which we are going to call this a standard logic, standard underscore logic, and then we could give it an initial value, or we can terminate it, which is terminated with a semicolon. And we'll do the same thing for the B. So we have our B, which is also an input, and we're going to give it a data type of standard logic and terminate it with a semicolon. Now we have to do our C, which is our output. So it follows the same format. We have a C, then we give it the semicolon, and we're going to say out for the direction, and it also will be a standard logic data type. Now the key, when we defined our last one, instead of a semicolon, we need to close the parentheses or the bracket of our port. So we'll close it, and then we'll do a semicolon, and then we want to use the keyword end to end our entity, and we want to give the name. So we're going to say end our AND gate. So that's going to define our AND gate entity. So we just have the very basic logic gate, and we want to give a semicolon as well. So this entity right here is defining the inputs and outputs of our design, which our inputs, we know we have A, B, and our output, which is a C, and the data type tells us the bits. So we know we have 2 bits going in, A and B, and 1 bit coming out, our C. The next part we want to talk about is the architecture of a design. So the VHDL, for the VHDL architecture, this defines how your design operates. So we have our entity, which defines the inputs and the outputs, and our architecture is going to define and explain how this actually works. So in the case of our AND gate, which we used, we know we have two inputs, A and B, and our architecture is going to tell us to AND those inputs, or logically AND them, to give us our output C. So this, if you're thinking about, like, for example, the buttons and LED project, our architecture is going to say, how do we define, we press a button, which is our input, and we have the LEDs, which is our output, but our architecture needs to define how are we going to process the inputs to determine the outputs. Because we also have the switch that either enables or disables our ability to light the LEDs when we press that button. And so that's the type of stuff that'll go on inside your architecture. So if you have a very complex VHDL design, almost all of your VHDL is going to be going inside that architecture. That's where the guts, or the entirety of your design is inside the architecture. So let's take a look back to the example of our AND gate, and let's define the architecture on our AND gate. So the way we'll do that is we want to use the keyword architecture. So it's just spelled as you would spell architecture. And then the next thing we need to do is name, what do we want to name our architecture? I'm just going to call it behave. And you can call this any name you want. And then the keyword of. And now we need to define the entity we're describing. So this is where the keyword where we named our entity AND gate comes into play. So architecture behave of AND gate is going to tell us that what we describe inside this architecture is all of our inputs come from the entity, and what we put as an output is also defined in the entity. And then we use the keyword is and the keyword begin. Say begin. And then we want to, in the middle here, after the keyword begin, we want to define how is our output going to be derived from our two inputs. So we know that we have our C signal, and we're going to give it the signal assignment. So our C is going to be the signal assignment of A, signal A, logically ANDed, so we'll just do the AND keyword with our signal B. And then we'll go ahead and close that statement with a semicolon. And then we'll do the end statement. So end, and here's we want to give it the name of our architecture, which is named behave. So we'll say end behave and give it the semicolon. So here we have effectively our entity and architecture of our AND gate design. We have our AND gate, which we defined with our entity, tells us our A and B as an input, our C as an output. We have our architecture, which is defined with the actual AND gate itself. So we'll put a little box there to show that this is the actual architecture we have right there. So our entity is our inputs and outputs, and our architecture is inside the design describing what's actually happening. So next, let's go ahead and open up the button LED project on your computer, and we'll take a look and see we have the entity for our design, which is defined entity, and we named it button LED. So what we want to do is we will uncomment the port. So we need to define the ports for our design. And we are going to have what we call our LED out. So we'll give it the keyword LED out, and we will say that is, we know that's an output, so we use the keyword out. And then we'll have to give it a data type, and once we get into the data type section, we'll decide what data type makes the most sense. The next keyword, or the next entity we want to describe, is our inputs. So we know we have a button, so our button underscore in, and this is going to be of a type in. It's going to be the input. We know we have one output, which is our LEDs we have described, and we have two inputs. So our button in as well as the enable. And this is what's going to enable or disable the output of the LEDs. And this is going to be an input as well. So right now we have some squiggly lines telling us that our entity is not properly defined, and that's because we have not defined the data type yet. And we will get to that when we cover the data types. We'll define the data type we want the LED out to be, the button in, and the enable. And so that defines our entity up to the point of what we need as well as the direction. And for the architecture, it gave us an architecture called behavior of button LED is, and then it gives us the begin and end behavioral. So in the middle is where we're going to add the actual, the design where we're going to say, okay, we take our button in and our enable and define what our LED out should be based on those two inputs. And when we cover that section, we'll put that here in the architecture of our design. And so that covers the entity and architecture lecture in this course.